Hello everybody, welcome to this session on system engineering in A-Spice perspective. Now why did I specifically say system engineering in A-Spice perspective? What exactly is this A-Spice perspective? First of all, please understand that A-Spice is being increasingly adopted by more and more automotive tier 1 and tier 2 suppliers. I will elaborate what is A-Spice and why it is being elaborated more and more used by tier 1 and tier 2 suppliers in the coming slides. Okay, this is the brief index. What is ASPICE, what are the various ASPICE capabilities, what is the system engineering in ASPICE perspective. First of all, what is system engineering, and the various levels of system, and finally we'll be touching upon the V model and also the various levels of software development, which includes SWE1, SWE2, SWE3, SWE4, SWE5 and SWE6. Okay, first of all, what is ASPICE? What does ASPICE stand for? ASPICE, or as it is commonly referred as automotive spice, stands for automotive software process improvement and capability determination. As if you see the acronym properly, the acronym itself is very self-defined. But anyway, I will explain elaborately little later. It is an automotive standard based on ISO 1000, 15504 and I also ISO 330XX series of standards. IS Automotive Spice, it allows the organizations across the automotive supply chain to assess and improve the capability level of their own processes as well as those of their suppliers. In simple words, A-Spice is a standard or yardstick through which an organization can measure the efficacy of the processes of their suppliers or efficacy or process of their own company also. In practice, automotive spice allows customers, OEMs and their multi-tier network to assess the process of their suppliers during the selection process. So, for example, if you are a OEM and you have several tier 1 companies which claim to be of equal standard, but you have to select one vendor, one tier 1 company. So what is the yardstick? What is the measure through which you decide, okay, this is the best tier 1 which is suitable to supply their product to me? That yardstick is A-Spice. I'll tell you what are the various scales of yardstick, what are the various scales of A-Spice in the coming slides. A-Spice has 6 capabilities levels in total, going from level 0 to level 5. Level 0 stands for incomplete process and level 5 starts for innovating process. A-Spice is increasingly becoming widespread in automotive industry with many OEMs and their multi-tier networks requiring all their suppliers to at least have automotive spice level 2 with plans to achieve level 3 for future projects or future in general. So nowadays it has become a common understanding that a tier 1 company to claim that it can be a suitable vendor to OEM must be of minimum A-Spice level 2. I repeat, minimum a tier 1 company or a tier 2 company to claim to become a vendor of a OEM, it should be of minimum A-Spice level 2 with plans to achieve, and many OEMs are planning to achieve level 3 for future products or in future in general. At least till now in whatever companies I have worked, we have reached level 2 only, and as I mentioned here, the last company I worked, they were also striving to reach automotive level A-Spice level 3. Now below figure clearly depicts the 6 levels of automotive spice and additional process attributes required for assessment of each level. So what is level 0? Level 0 is incomplete. It means that there is no process which is which is uh, completely which is completely established. Level 1 means it is managed to a good extent, but still there are some process differences and discrepancies which cannot be which cannot be fulfilled. And level 2 is managed. Level 2 is managed and level 3 is established. Established means here the process are well established, and but still there is some discrepancies because of which you cannot predict what exactly is output. And level 4 is a stage where processes are so well streamlined that you can predict to a good extent, or with reasonably good accuracy, what exactly is the output. And next is innovating. Now, innovating stands for a level where processes are continuously improving, where there are streamlined metrics, where employees constantly strive to enhance or improve the process capability. It may be reducing the cost of production, or reducing the time of production, or increasing the quality standards. But it should be a company where processes are constantly striving to enhance their process capabilities. Now, what is system engineering in ASPICE perspective? The ASPICE system engineering process group is a set of processes that ensure systems are developed in a structured way. I will tell you what exactly a system is. Of course, everybody knows what a system is, but in exact automotive software perspective, or in automotive product perspective, what exactly the system, what exactly is definition of system, there is a very clear cut definition which gives a very clear cut meaning, which I'll be explaining a bit later. The process is based on V model and includes the following step. Again, I assume many people are familiar with V model, but nevertheless, in the later slides, I'll be explaining what V model is. But for now, you understand V model is a systematic process through which you develop a system. And this structured way to develop a system has various steps, which is called system 1, or sys1 as it is usually pronounced. It is requirements elicitation. Requirements elicitation means the process of gathering requirements for a system. What is the meaning of requirement? Of course, in ordinary English, everybody knows what is requirement, but what exactly is the meaning of requirement in this particular perspective? We'll touch upon it in the coming slides. And next, what is system requirement analysis? The process of analyzing the system requirements. So who will be analyzing the system requirements? Where does the sys1 end and where does sys2 start? All these things I will be clearly explaining. But for now, you please go through this list. Sys3 means system architecture design, the process of designing the system's architecture. What is system architecture? I'm sure everybody knows what is meant by architecture. For example, in a perspective of a home, what is the what is the meaning of architecture? Where is the drawing room? Where is the bedroom? Where is the bathroom? Where is the kitchen? How exactly they are going to be connected with each other? That is the meaning of architecture of a house. So what is the meaning of systems architecture? System architecture also, it almost means the same, which clearly explains where exactly which components are lying, which components are lying where, and how are those components interconnected with each other. That is clearly elaborated by a system architecture design sys3. Now next is system integration and integration test. The process of integrating and testing the system. Now once you integrate all the components, once you design the components and you clearly define the architecture, you integrate it. You integrate it into a full scale system. And once the full scale system is integrated, then you try to test the system, whether the system is following the system is fulfilling the requirements, whether it is following this process. If a system is put through a certain number of tests, whether is it passing the test or whether it is failing the test. Because a system which does not pass the test is not of any use to the end consumer. So system integration and integration test is a very important part of system engineering. And now what is meant by system qualification test? Now this is the final step and the most important step. Here it is the engineer who clearly signs off that the integrated system, it is meeting the system requirements and customer expectations, and it can be productionized. Okay, one important thing is this system engineering comes into picture during the development of prototype. Once the prototype is developed, once it is bulk productionized, all these elaborate steps, they can be skipped. So keep in mind that development of a prototype demands a very structured approach, and that approach is defined in system engineering. Now what is meant by V model? The system's development life cycle is represented graphically by V model. Now Again, I assume many people know what is meant by V model, but let me slightly elaborate. The V model is used to create a project management and development life cycle models that are rigorous. So to develop a project, to develop a system which is complicated, this V model is very useful. Actually, this V model has its origin in Germany. It is a general testing model, and also US standard are also and as per the US government standard, there are three main categories into which V model or can be divided. Now, what exactly is this V model doing? The V model encapsulates or it captures the primary actions that must be performed in tandem with the associated deliverables inside the project lifecycle development or computerized system validation framework. Now, this is definition. I just read out the definition. Now, just to elaborate the definition, you have to clearly understand that there is a deliverable at each and every step of the development. In the previous slide, I clearly told you what is system 1, what is system 2, what is system 3. So, at the end of each and every system level or system gate, there is a clear cut deliverable. So we have to ensure what actions must be done to ensure a proper deliverable. It outlines the tasks that must be completed and the outcomes that must be achieved during the product development process. For example, in the SIS2, we clearly analyze. In the SIS1, we clearly elicit the requirements. So what are all the requirements? And based on the requirements, what are the design constraints that must be taken into consideration? All these tasks, they have a clear-cut deliverable. When you say system 2 analysis, design analysis, when you say design, you must have a clear-cut specification of the design. Whether it is the manufacturing margin or the engineering margin, or whether it is the machining allowance, whether it may be temperature allowance, or it may be an ambience allowance. All these things must be clearly captured. So at each and every level of the V model, we have a clear-cut deliverable, and identifying the deliverable at a at every gate of the V model is very important. So this system or developing the system right from requirements engineering to just a minute, I will just highlight, from requirements engineering to system creation is called V model. Now the breakdown of the requirements and development of systems, I will first read this, and then I will explain. The breakdown of requirements and the development of system specifications by the left side of the V. The V's right side symbolizes the integration of the components and their verification. The right side, it is more concentrating on the integration of the components, the design of the components, the verification of the components. However, the requirements must be first verified against the user demands or a higher level requirements. Additionally, there is a validation of the system model. Now, I'll explain you the reason difference between verification and validation very clearly. Just be patient. However, the requirement must be verified against the user demands. Additionally, there is a validation of the system models. And it may not be accurate to say that validation solely takes place on the right side. The simplest way to put it is that validation is always done against the demands of the user in the real world. As you can see, let me go back to the previous slide. Just a minute. Okay. I'm not able to go back. In the V model, if you had seen, I'll just draw a picture. In the V model, you have seen the various levels. At each and every level, the output is it being meeting the requirement. For example, system elicitation has its own requirement testing. Analysis has its own testing. And again, architecture has its own testing on the right side. So every component that is being delivered on the left side is being validated on the right side. So this is the standard called V model. Okay, now I know understanding on the first time when I'm explaining this is slightly difficult. So if you go through the V model a couple of times, you'll clearly understand. Now, what is meant by verification and validation? What's the difference between validation and verification? Validation, the assurance that the product, service, or system meets the needs of the customer and the other identified stakeholder. It often involves acceptance and the suitability with the external customers. So once an external customer For example, you buy a car. Purpose of car is to take you from point A to point B. Now, if I am driving a car and if it is successfully the car is taking me from point A to point B, I can validate that the car is delivering its purpose. Now, what is meant by verification? The verification means the evaluation of whether or not a product, service, or system complies with the regulation, requirement, specification, or imposed condition. Now, this is more like a legal term. This is something which is internal, this is something which internally has to be taken care of. Now, as an end customer, I don't need to take care whether a vehicle is meeting Bharat stage 6 norms or stage 7 norms. I can just drive the car. But as a OEM, you have to verify that a vehicle is meeting the stage 6 norms or stage 7 norms, and that is called verification. A vehicle manufacturer has to ensure that the vehicle is meeting all the legal requirements. And legal requirement does not mean only emission requirements. It can be any manufacturing compliance also. It can be maintenance compliance also. So the point is, verification is strictly internal, and validation is something which an external stakeholder justifies. What are the various objectives fulfilled by using V model? The V model provides guidance for the planning and realization of the projects. Now, V model gives a very systematic approach to development of the model. Okay, first time when I came across V model, even I was totally at sea. I could not understand what this V model is, but once I started using V model, I understood the efficacy of the V model and how easy it becomes once you start implementing the V model in development of your features or development of your functions, especially in ADAS, because we are more interested in ADAS also. We can clearly understand the importance of V model in development of ADAS functions. So what are the various objectives fulfilled by V model? Minimization of project risks. The V model improves the project transparency and project control by specifying standardization approach and describing the corresponding results and responsible roles. So when you develop projects, you need to have a proper deliverable at each and every gate, which I already emphasized. And V model also clearly emphasizes who is responsible for what. So there is separate requirements elicitation engineer, there is separate analysis engineer, there is separate architect. All these clear-cut responsibilities are clearly allocated and apportioned to the right people. And improvement and guarantee of the quality. As a standardized process, the V model ensures that the results to be provided are complete and have the desired quality. Okay, now this software quality is something which has to be ensured or guaranteed, and this V model ensures that the required software quality is met. Now, reduction of total cost over the entire project and system life cycle. This actually V model is a waterfall method. It is not exactly agile method, but still it is very efficient. It clearly reduces the cost. It clearly reduces the system life cycle in a very transparent manner. Understand this word. Let me highlight this word in a very transparent manner. It reduces the cost and also enhances the system life cycle. How? By applying a standardized process model. The results obtained are uniformly and easily retraced. And also, I will be discussing about the traceability. For now, you just by heart this word. I won't say by heart, but just note that the results are easily traceable or easily retraceable. For example, in case there is any discrepancy, or in case there is any mistake, or in case the system is not meeting a particular requirement, you can easily trace back where exactly the fault is lying. Okay, now improvement of communication between all stakeholders. The standardized and uniform description of all relevant elements in the terms is a basis for mutual understanding between all stakeholders. Thus, the frictional loss between the user, acquirer, and the developer is reduced. So, this clearly reduces the friction or misunderstanding. So, it gives a very clear-cut communication between all the various stakeholders. System engineering and verification. So at last we have come to system engineering and verification. Now what is meant by system engineering? The system engineering process provides a path for improving the cost effectiveness of complex systems as experienced by system owner over over the entire life of the system from conception to retirement. Now what is meant by conception here? here I'm talking about the requirement elicitation. And when you say retirement, it also means, okay, in this perspective, we can say retirement means acceptance of the system by the end consumer. But it also means till the end product is scrapped. For example, if you buy a car and use it after 8 years, I may scrap the car. That also can be referred as retirement, because sometimes when you develop the system, you have to take care that even after it is bulk productionized, even after the product goes to the customer end, it does not have any problem. That comes under that is what is referred as retirement. It involves early and comprehensive identification of goals, a concept of operations that describes user needs and operating environment, and a thorough and testable system. This word is very important. A thorough and testable system requirements. Now, how do you develop the system requirements, testable requirements? What are the various use cases? All these things we will be touching upon as we go to the SIS1, SIS2, SIS3 level. Detailed design implementation, rigorous acceptance testing of the implemented system to ensure it meets the stated requirements, measuring its effectiveness in addressing goals, ongoing operation and maintenance, system upgrades over time, and eventual retirement. So this is all I mentioned. So as for example, here it clearly mentioned system upgrades over time. Let me give one example where a system can be upgraded even after the consumer buys it. The system is called over the air. Even after a consumer buys a car, the software can be upgraded over the air by the OEM. That is what is being referred here. Even developing such a system becomes very easy when you follow this system engineering procedure. Now I want all of you to go see this slide very carefully. I request all of you to pause the video and spend some time here. The process emphasizes requirement driven design and testing. The design is clearly driven by the end consumer and the end requirement. And all the design elements and acceptance tests must be retraceable to one or more system requirements, and every requirement must be addressed by at least one design element and acceptance test. Now there is a bit clearly understand that every requirement must be addressed by at least one design element. So there must be a proper design component, a component which is clearly designed to meet the requirement, and there must be a proper test, a proper internal test. Here, what am I referring to? Am I referring to validation or verification? I'm referring to verification. So a element should be clearly allocated to an acceptance test so that it can be tested and it can be given to the end customer that this design component will serve the purpose without any future problem. Such rigor ensures nothing is done unnecessarily and everything that is necessary is completed. And that is taken care by system engineering. So you have to make sure that every act, every task you are going by is absolutely necessary and you are not at all doing anything unnecessary. It is important to do everything necessary and to eliminate everything that is unnecessary. And that is what the system engineering clearly takes care of. Okay, thank you.